Hello, this is Dr. Stephen Harkins. Welcome to page 19 of Anatomy Coloring Book. This lesson will cover the axial and appendicular skeleton. And what is the difference between those two? Well, axial means along an axis, right? So you can always think about it that way. The axial skeleton is everything that lies along this axis. So the skull, the vertebra, the rib cage. And let's cut in here, actually, the spine, the tailbone, the pelvis, excuse me, not the pelvis, but the spine. There we go, up the rib cage again, not the scapula, but here, the rib cage and the skull. There you go. It's the spine, everything that lies along this axis, the vertical axis, the y-axis of the human body. That's called the axial skeleton, and I'll diagram it here. Here is the axial skeleton, including the spine, the sacrum, the rib cage, the sternum, everything in line with this axis here. The appendicular skeleton, appendicular, think appendages when you think appendicular, is everything that is not along the axis. So it is our appendages, it's our arms and our legs. This is your appendicular skeleton here, including your clavicle, your collarbone. These are your appendages. So anytime, here we go, and your pelvis here, your legs, these are your appendages. So anytime you hear reference to appendicular skeleton, you know they're talking about your appendages. Your legs, your arms. There we go. Why not just continue it out, right? Your appendicular skeleton. Your blades, your shoulder blades, these are called your scapula. There you go, and your arms. They are also part of the appendicular skeleton, not to be confused with the axial skeleton. So there you have it. And why don't I just superimpose and draw the axial skeleton, or circle the axial skeleton here. Here it is, down the spine. Here, oh, let's grab the ribs in there too. Yep. There we go. That is your axial skeleton versus your appendicular skeleton. Now, the appendicular skeleton and the axial, for that matter, contain different types of bones. They contain long, short, flat, irregular, and sesamoid. So let's start with the long bones. What are they? Which bones are long bones? Well, that's pretty obvious. Your humerus right here is a long bone. Long bones consist, as you know, of a diaphysis, a shaft with a medullary cavity in the middle where that marrow lies, that red marrow that contains creates your red blood cells and your white blood cells, for that matter, and your epiphysis. So your epiphysis and your diaphysis. And you can see some more other long bones here. The ulna, the radius, you can see they have an epiphysis on each end and a long shaft. Those are obvious. Your femur right here. Long bones, right? There's your tibia right here. That's a long bone. You see the epiphysis right here and here, and then the diaphysis, the shaft and the epiphysis on both ends. Your fibula right here, look at the epiphysis right there, the epiphyses, and the shaft. Here's your femur again. On this side, here's your epiphysis, yes. And your epiphysis here, epiphyseal, your epiphysis. Then, and here, of course, your ulna here, humerus again. These are your long bones. Clavicle looks like a long bone to me. Then you have some other bones, short bones. And short bones consist of, or I should say do not consist of, a diaphysis and epiphysis. They are your carpal bones. They are the little bones right here of the hand and feet, the carpals. And they are short and sort of roundish. And here are the tarsal bones in your feet right here. And here's more carpal bones. And they are cube shaped. They are cancellous bone, in other words, kind of hollowed out in there, right? With a thin cortex of compact bone and have no cavity. Excuse me, they're not hollowed out. They are cancellous bone or spongy bone, somewhat hollow, with the trabeculae, lying throughout. So it might look like this with trabeculae, those spider-like projections in there of bone. Flat bones are the cranial bones here. The cranial bone is a flat bone. That means the head. Cranium means head. And for obvious reason, there are different bones in the head connected by sutures. And they are obviously called that way for a reason. They are flat in nature. So the skull bones. What else is a flat bone? This one right here. This is called your scapula. It's a flat bone for obvious reasons as well. Here it is, and from the front view, it's kind of hidden by the rib cage, but it goes back behind here. Here's the right scapula, and it is obviously flat-shaped. Also the ribs, if you were to feel a rib, and you can kind of see here how a rib has kind of a flat nature to it. It's not round. It doesn't have an epiphysis and a shaft per se, but yeah, relatively flat and compared to other bones, obviously creating a difference between no two epiphyses and a long shaft. They're just flat and kind of rounded. Irregular bones. Irregular bones are just any bone that's not shaped like a short or a long bone or a flat bone. One example is a vertebra right here. Observe the funny shape of a vertebra here. And it's got wings on it, and it's got a projection that comes out the front. Here are those sort of wings, the transverse process. There's all kinds of processes or bumps and things poking out of it, and sort of wings, and very much irregular shaped bones. Lastly, the sesamoid bones. Sesamoid bones are bones. The biggest sesamoid bone in the body is the patella right here. It's your kneecap bone. It's a circular shaped bone, and there are others also in the tendons of your feet, for example. And what's unique about these bones is that one side of the bone, so this might be the top of your patellar bone, okay? It might look like that. But when you flip it over to the other side, it will have like articulating surfaces on it with cartilage on one end, very, very slippery cartilage. And this the slippery cartilage, as you can imagine, when we turn that over, we want that cartilage to be nice, that bone to slip and slide nicely over the femur right here in this little groove contained by or created by the femur. And another unique thing is that sesamoid bones are sort of enveloped inside a tendon. So here's your muscle, here's your quad muscle right here, right? There's your rectus femoris muscle and your vastus, a lateralis, vastus medialis, and then there's a tendon that comes off of these muscles. You know what? Yeah. I will make the tendon. There's the muscle in purple, and the tendon comes off and envelops literally, like puts the patella in an envelope, and then attaches to the bone right here on the tibial tuberosity over here. Okay, so it would be like this muscle here coming down and then completely enveloping and engrossing that and attaching right there. So this patella is actually contained inside of a tendon with a very slippery bottom on it to slide along the femur when your knee bends and straightens and bends and straightens. The underside of it is very, very slippery to run up and down along, sort of slightly up and slightly down along your femur there. And so sesamoid bone is just a There you go. It developed in tendons, like the patellar tendon, mixed with bone and cartilage. So it's like cartilage on the bottom, slippery cartilage on the bottom, and then bone on the top, and developed inside the tendon. Also, on the bottom of your feet, there are sesamoid bones that are similar to this, but tiny, tiny, tiny little sesamoid bones on the bottom of your feet that form a very similar function. You can see they resist friction because they're slippery on the bottom, right? They enhance joint movement and assist in local circulation. All right, this is page 19 of Anatomy Coloring Book. This is Dr. Stephen Harkins. Until next time.